Okay, let's get stuck into this Easter revision Chemistry 2 foundation paper. Lovely. So, here we go. This is about halogens, group 7. Always look at the top of the page. I told you this already. Listen to me. I know what I'm talking about. So, chlorine, bromine, iodine, what colour are they and what state are they, gas, liquid or solid? So, you've got no colours here. So, this is yellow / green. This is reddy brown. And this is solid. Okay, there's nothing more to say about that, it's got to learn it. Use a hazard symbol such as safety precautions a chemist should take when using bromine. That's going to hurt you if you spill it on your hands, so let's wear some gloves. Gloves do not spill on skin. And this one is harmful. Do not inhale. Okay, let's carry on. Magnesium reacts with bromine to form magnesium bromide. Write the word equation. When it's giving you, so magnesium plus reacts with bromine to form arrow magnesium bromide. Just pop them in. No issue. No need to get your knickers in a twist of that one at all. Bang bang, thank you, man. Right. Next one. Sodium reacts with chlorine to form sodium chloride, which is the form of sodium chloride. Got no symbols. You should know this all day long. You know sodium's Na. It's either one of those, and Cl, that's an oxygen. It's got nothing to do with oxygen, has it? That's why it's that one. Turn over. Now that question, first question, went swimmingly well. Mixtures and compounds. Chromatography here. Look, we did this in class. So ink W's got that dot in, ink X got those 2 dots in, ink Y's got that dot in, and ink Z's got those 2 dots in. So state the letter of ink that contained only one coloured dye. Which one's only got 1 dot? Ink Y, of course. Ink Y. Easy marks. Next one, please. Ink W has been made by mixing 2 of the other inks together. State the 2 inks that could have been mixed together to make W. So W, you just go across until you hit something. So you got this, ink Y, and ink Z have made that. Z have made that, simple. A mixture of oil and water is best separated using a separating funnel. That's that stupid device that we had in class. Got a tap on there, you got your oil and you got your water, you just open the tap until that water runs out and you turn the tap again. Oh dear dear, we haven't got to market, beautiful. Which are the table? So, covalent liquid. You've just got to know the structure of covalent, the properties of covalent bonds. So, boiling point, they've got a low boiling point because CO2 is an example of a covalent bond, a simple covalent bond. So we know CO2 boiling point is low because it's already gas in the atmosphere. Leo Dale told us so. So, low, and it doesn't conduct electricity, so it's there. Okay, try and do it by elimination. Hydrogen chloride can be formed by reacting H2 with Cl2. Write the balance equation. Right, okay. So that's formed this time. So that's at the end. H2 plus Cl2. Now there is a problem here in that you've got 2 hydrogens here and 1 hydrogen there, 2 chlorines here and 2 chlorines there. Now the way you've got 1 marker ready for doing that. Now the way to balance it is if you just put a big 2 in front of that, and that will balance it there. So you've got 2 H's because that's equivalent to doing that and that. Draw a dot cross diagram to show the electron arrangement in a molecule of hydrogen chloride. Ooh, cheeky. So show outer electrons only. So you've got HCl, so you've got hydrogen, chlorine, but only once the outer electrons. Chlorine is in group 7, so the outermost shell it's got 7 on. So that's what they like to start with. Now it's a covalent bond, so we're just drawing those together. You don't need to do that first step if you don't want to. I'm just showing you where I'm coming from. And then you overlap H. There you go. 2 marks. Done. Covalent bond. One bam, thank you, ma'am. Let's move on. Put across, which is the form of cation. Cation. Okay, cation is the positive ions, so it's Na plus. The form of potassium ion is K plus. The carbonate is to minus, which the following is the formula. So we said plus CO3 2 plus. You write them out again. You transfer down. And then that's obviously a 1 because it's got a number, so it'll just be K2CO3, which is there. See? When dilute has got carbonate gases evolved, describe the test for the gas. Well, the gas is carbon dioxide, so CO2 is released, which turns lime water cloudy. Basically, it's asking you, when you put an acid with a carbonate, what do you get? And you get CO2, just from your tests. Right. Barium nitrate solution in the beaker, a white precipitate, and this is a solid, isn't it? Solid coming out of solution. Forms in a mixture. Describe how would you obtain a pure, dry sample from mixture in the beaker. Well, you need to filter it. And then you need to rinse it with water. The filter paper and leave to dry. And then you've got barium sulfate will be present on your filter paper. Lovely. One mark. Magnesium oxide is an ionic compound. The electronic configuration of magnesium is 282. The electronic configuration of oxygen is 26. Describe in terms of electrons how magnesium atom and oxygen atom form ions 2. So, I mean, we've done these loads. So, this magnesium is going to give up these 2, and that's going to go to there to make that 8, so they're both happy. But in terms of writing this, I'll just say magnesium loses 2 electrons and becomes a 2 positive ion. Oxygen gains these 2 electrons and becomes a 2 negative ion. Opposite charges cause them to bond. 3 marks. Done. Right. Next one. Calculate the relative formula mass. So MgO. We did this. That's 24. That's 16. Add them together and you get big fat 30. You get big fat 40. Question 4. Over halfway through the paper. Well, halfway through the paper. So we've got rates of reaction here. The word equation for this, you've got magnesium hydrochloric acid giving you magnesium chloride and hydrogen. Explain the difference between magnesium chloride AQ and magnesium chloride liquid. So AQ means it's dissolved. Okay, so AQ means it is dissolved in water. And that's enough for the 2 marks. Describe what you see when magnesium ribbon reacts with dilutes. What do you see? What do you see? What do you see? Well, you're going to see it either disappearing, you're going to see it bubbling, or you're going to see the thermometer increase in temperature. Getting warm just wouldn't cut the mustard there. Please read the questions. The reason for it to be bold, they're asking you to read it properly, man. Right, every 20 seconds the student recorded the total volume of hydrogen produced in the reaction. Name the piece of apparatus the student used to measure the volume produced. So, what is the piece of apparatus that they're going to use? So, they're going to use a gas syringe. Or you could have measuring cylinder, upturned measuring cylinder. That's what we used in class. Cylinder spelled wrong. Sorry, it's sloppy that is. You know, remember when we did this, and we went into the water, and we had a measuring cylinder there, and we just waited for it to displace all the water in there. Total volume of hydrogen, so it goes boom. So how many seconds all the magnesium reacted? So all the magnesium reacted when the line starts to flatten out. The line's flatten out there, 140. It'll accept 136 to 144. So that's not too bad. On the graph, draw a curve to show the volume of gas changes during the experiment. So we've got more concentrated. More concentrated is going to go faster, so it's going to go steeper, so it's going to get to the end point quicker. So you want a line inside this line, it's going faster, fast, but it doesn't go up there. That's a load of rubbish. Okay, it just reacts faster. Explain the effect on the rate of reaction using magnesium powder and magnesium ribbon. So magnesium powder will increase the rate of reaction because that's got a large surface area. So magnesium powder has a larger surface area, which means there is more chance of a collision. Therefore, the rate of reaction increases. When magnesium reacts with dilute hydrochloric acid, there is a change in temperature. In the experiment, the results were start, change, explain what conclusion, the type of reaction. Temperature's gone up. Imagine that. 21 up to 62. So this is called an exothermic reaction. As one mark, as the temperature has increased. Lovely. Lovely jubbly. Oh dear, question 5, we're nearly there now, aren't we? We only needed 35 marks and we've got all of them so far, which is excellent. I know you would have got them all as well, brilliant. Relative mass, proton 1, neutron 1, electron is very small, okay? You can put very small if you want. The answer is actually 0.0006, but very small. Let's just remember to put very small. An atom has no overall charge because it contains equal number of electrons. These are negatives, these are positives. So if it's got the same number of them and them, it's going to cancel each other out. So that's there like that. The atomic mass of 3, the atomic number is 3, atomic mass is 7. State the number of each of the particles in this atom. So, each of the particles. So, lithium, 7, 3, smallest number. So, 3 protons, 3 electrons. The difference, neutrons. How many times I've done that with you, I do not know. Right, here's some information about the periodic table. In the periodic table, elements are arranged in rows of columns. The position of the element depends on its atomic structure. Elements with chemical properties. There's a lot of words here, but we've got to read them. Can't just jump on. Found in the same parts. Identify parts of the periodic table and explain how the position of an element, the periodic table against its chemical properties and atomic structure. You're provided with the outline. So, what shall we talk about? Well, let's talk about the things that we had lessons on. Talked about these alkali metals. 1, 2, 3, 4, 5, 6, 7. Talked about them, halogens. And we talked about them, noble gases. That's what we discussed in the lesson. So, and we also talked about groups and periods. So, the periodic table has groups, and every element in a group behaves in a similar way. This is because they all have the same number of electrons on their outermost shell. Job done. So, that's all about groups. Right, let's then talk about periods. Periods go across the periodic table, and elements in the same period have the same number of electron shells. Done. Right. Group 1, you find the alkali metals. Group 7, you find the halogens, and group 0, you find the noble gases. The last thing we can say, well, two things. These are all metals, these are non-metals. The section to the left of the dark line are metals, and to the right are non-metals. In the centre section, transition metals. The centre of the periodic table is where transition metals are found. Boom. We could go on. I mean, how much have I got any more space? I have, and I probably would go on, because you can say that as you go down here they get more reactive, and as you go up there they get more reactive. But that, to be fair, has probably picked us up a good number of marks. All of them, I guess. So that's that done. Let's keep going. Question 6. Nearly there now. You've got to keep going though, guys. You can't flag. I've been doing this for 20 minutes now. I have raced through it, so you've got plenty of time. I'll explain why diamond has a high melting point. Right, it's a giant covalent structure. And the bonds are strong and therefore need a lot of heat to break. So it's basically these bonds are so strong that if you want to break them, you've got to give thousands of degrees to break those bonds. They're very, very strong. We calculate percentages by mass. So it's told us that the relative formula mass of this is 111. It tells us there, look, I'm going to calculate that. So if this is 111, what percentage of it's calcium? Calcium's 40. There's one bit of calcium. So it's 40 over 111, which is 0.36 times by 100 gives you 36%. Right. Which are the solubility of calcium chloride and barium sulfate in water? So you should be knowing chlorides are soluble and sulfates are insoluble, so we are here. 1 mark. That's the last question. Yeah. Okay, I'll answer this question on the podcast. I've got to go now. So, thank you for listening, and hopefully you picked up enough marks about this question. This question's quite easy, actually. I will do this in part 2. Thank you. Bye-bye.